Okay, here we are, Geometry and Data Interim 3 Study Guide, finishing up page 4 with problem 9 I just left off on. I'm talking about interpreting the slope in terms of this graph. And just to be a little more specific, if you think of slope as rise over run, rise is your change in y, which is the change in your dependent quantity. Over run would be your change in your independent quantity. So it would be pounds per inch. All right, moving on to number 11. The table is showing education of family members in a single family. If one person is chosen at random, what is the probability that they've obtained either a master's or bachelor's? Well, 2 people had a bachelor's and 3 people had a master's. So altogether, that was 10 people out of a total of 40. So what's that probability? Well, if you reduce it as a fraction, it would be 1/4, or as a decimal, 0.25. Page number 5, starting with problem number 12. The table below shows the number and type of car sales sorted by gender at a local dealership. If the sale was chosen at random, what's the probability that the car was sold was a sports car given the buyer was a female? The words given that the buyer was a female is a hint to me that this is a conditional probability question. And I'm only going to look at the row for females. So what's the probability that it was a sports car? Given that it was a female, 45 females bought a sport car out of 180 purchases in total for females. So if you do 45 divided by 180, I get 0.25 is the probability. Number 14. In the diagram below, quadrilateral ABCD is congruent to EFGH. Describe a sequence of transformations, that should say, not translations, that will map quadrilateral ABCD onto quadrilateral EFGH. So that should say transformations. Sorry about that. If you take a peek at this, it would take, you could talk about it in either order, but I would say a translation, okay, 4 units left, and I'm looking at point D, 1, 2, 3, 4, would get it onto the y-axis, followed by a reflection over the x-axis. Some people might call that also a vertical reflection. That would map that onto the image, the pre-image to the image. Number 15, use the information in the diagram to find AB. Well, I'm looking at these triangles. I know that vertical angles are congruent, and because of angle-angle similarity, because they both have 2 angles that are congruent to each other, these 2 triangles are similar, which means their sides are proportional. So if I'm looking at these triangles, I see that the side 120 is between the 38-degree angle and the vertical angle. And on the other triangle, the 80 is between the vertical angle and the 38-degree angle. So therefore, these 2 sides correspond to each other. So I can set up a proportion. I'm going to do the triangle on the left to the triangle on the right for my proportion. And I'm going to do, I have 120 over 80, since those sides go to each other, equals, looking for a B, so I'm going to call that X. So X, and then what side corresponds to X would be the 48. I would finish solving this off with cross multiplication, and so I would have 80x equals 120 times 48. And I have 50, 760. There are, of course, some other ways you could do this. By reducing the fraction down sooner would give you much smaller numbers. Either way, I find out that the value of AB is 72. Number 16, which triangle similarity theorem would be used in order to show the 2 triangles are similar? And write the triangular similarity statement. Well, I know that angle A corresponds to X. And now what I need to do is test to see if the sides are proportional. So what I'm going to do is I'm going to take the small side from the triangle on the left, which is 15, and compare it to the small side of the triangle on the right, which is 10. So 10 and 15, I'm going to see if this sets up a proportion, meaning are these two ratios equal? I'm going to take the larger side on AC, which is 21, and compare it to the larger side on the other triangle, which is 14. And if you reduce these fractions down, they both equal 3/2, or if you had done 15 divided by 10, you would get 1.5 equals 1.5. So therefore, the sides are proportional and their included angle is congruent. So therefore, I can say triangle ABC is similar to triangle. Let's see, AB went across that smaller side from the 75-degree angle, so it would have to be X, Y, Z by side, angle, side similarity. Moving on to page 6, last page in the packet. Yay! Number 17, given triangle RST as shown below, which two sides are congruent to each other? Well, this is an isosceles triangle, and what I know about isosceles triangles is because the converse of the isosceles triangle theorem says that if the base angles of a triangle are congruent, then the sides opposite of each of those angles are also congruent. So SR is congruent. Let's see, that's a terrible, to ST. All right, number 18, in the diagram, parallel lines B and C are cut by transversal T, with the measure of angle 1 being 114. Find the measures of the other 7 angles. Well, I know 1 and 2 are a linear pair, which means they add to 180. So if I subtract 114 from 180, I get 66 degrees. So angle 2 is 66. I now have the only 2 measures that you're going to find for all of these angles. Angle 4 would also be 114 because 1 and 4 are vertical angles. 2 and 3 are vertical angles, so 3 has to be 66. Now I'm going to move down to the other intersection. Angles 1 and 8 are we call alternate exterior angles, so 8 also has to be 114. Angles 1 and 5 are corresponding angles, so 5 has to be 114. Let's see. I know angles 4 and 6 have to be supplementary. Those are called same sign interior, or 6 corresponds with 2, or 6 and 3 are alternate interior angles. Either way, 6 is 66, and that leaves 7 to also be 66 degrees. Number 19 is a really tricky problem, and at first glance you might think it's impossible to solve. They want me to find the value of X right here. And so I want you to stop and think about, what do you know about the interior angles of a hexagon? Well, if I were to draw in, picking from one vertex to all other non-adjacent vertices, I know that I can draw in 4 triangles. And so 180 degrees times 4 triangles gives me the total interior angles of a hexagon are 720 degrees. You might have used the formula 180 times n minus 2, same thing. So the total number of degrees in a hexagon is 720. Now, what I'm going to do is figure out what angles do I have and see if I can figure out what's left would be the angle I'm looking for. To do that, I'm going to suggest, let's call this angle M here, this interior angle M. I'm going to call this angle Z, or Z degrees. And imagine Z and Y are a linear pair. So therefore, I know Z and Y together add to 180 degrees. So it doesn't matter that I don't know either of these angles, but what does matter is that I know that together they add to 180 degrees. And so since this Y is congruent to this Y, I can essentially substitute that value in and think of the angles Y and Z adding to 180. So now from here, if I have 180 degrees between angles Y and Z, I have 127, 126, and 125 degrees. If I add all those angles up together, I get 558 degrees. So if I take the total degrees of 720 and subtract the 558, I get a measure of 162 degrees for angle X.